Have you ever gazed at the night sky and wondered how it all began? This is the profound question that has piqued the curiosity of humankind throughout history. From ancient philosophers to modern scientists, many minds have proposed theories to elucidate the origin of the universe. Imagine a cosmos filled with mysteries, waiting to be unraveled. Are you ready to embark on a journey across time to explore the theories of the universe's origin? Buckle up, it's going to be a fascinating ride. Dating back to the ancient times, humans have been intrigued by the cosmos. Our ancestors stared up at the night sky, awestruck by the twinkling stars and the vast expanse of the universe. Their curiosity led to the development of the earliest cosmological theories. The ancient Egyptians, for instance, believed in a flat earth with the heavens held up by 4 pillars. They envisioned the sky as a goddess, Nut, bending over the earth, her body studded with stars. This cosmology was deeply intertwined with their religious beliefs and rituals. In contrast, the Greeks took a more philosophical approach. They proposed the geocentric model, where the Earth was at the center of the universe and everything else revolved around it. This model was supported by 2 very influential Greek thinkers, Aristotle and Ptolemy. Aristotle, with his strong influence on science, philosophy, and logic, argued that the Earth was stationary and that the heavens moved in perfect circles around it. Ptolemy later refined this model, introducing the concept of epicycles to account for the apparent retrograde motion of the planets. Moving to the Far East, the ancient Chinese also had their unique cosmological view. They believed in a flat, square Earth under a round, dome-like sky. The sky was seen as a celestial sphere surrounding the Earth, with the stars attached to this sphere. This cosmology was deeply rooted in their philosophy of balance and harmony between the Earth and the heavens. These theories, intriguing as they are, were the product of observation and philosophical contemplation, not rigorous scientific investigation. They were based on what our ancestors could see with their naked eyes and interpret with their understanding at the time. As we moved into the Middle Ages, our understanding of the universe began to change significantly. But before we delve into that fascinating era, let's take a moment to appreciate these ancient theories. They represent the first steps humans took in trying to comprehend the cosmos, laying the foundation for the scientific exploration of the universe that would follow. The 16th century marked a turning point in our understanding of the universe. Enter Nicolaus Copernicus, a man who dared to challenge the Earth-centered model of the universe. Instead, he boldly proposed a heliocentric model, positioning the Sun, not the Earth, at the center of the universe. This was a groundbreaking shift in perspective, a shift that turned the world quite literally on its axis. The Earth was no longer the static center around which everything else revolved. Instead, it was one of many planets orbiting the Sun. Copernicus's heliocentric model was met with both intrigue and resistance. It shook the foundations of the scientific community, challenging long-held beliefs and sparking debates that lasted for centuries. Yet it was this very controversy that drove the pursuit for truth, pushing scientists to question, explore, and ultimately expand our understanding of the universe. Despite the initial resistance, the heliocentric model gained acceptance over time. It offered a simpler explanation for the observed motion of the planets and laid the groundwork for the laws of planetary motion that Johannes Kepler would later formulate. The Copernican Revolution was not just about a change in cosmological models. It signified a shift in thinking, a willingness to question the status quo and seek answers beyond the established norms. It was a pivotal moment in the history of science, a moment that forever changed our view of the universe. The Copernican Revolution paved the way for the next big leap in cosmology, the Newtonian Revolution. Isaac Newton, a name synonymous with physics, gave us a new perspective on the universe. Newton's laws of motion and universal gravitation, which he formulated in the 17th century, were revolutionary. They provided a framework that helped us decipher the universe's structure and dynamics. Newton's first law, the law of inertia, tells us that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. This law gave us insight into how celestial bodies maintain their orbits. His second law, the law of acceleration, quantified the relationship between force, mass, and acceleration. It revealed that the force exerted on an object is equal to the mass of that object times its acceleration. This law helped us understand how planets move faster when they're closer to the sun. Finally, Newton's third law, the law of action and reaction, states that for every action, there is an equal and opposite reaction. It explained why planets don't just spiral into the sun under its gravitational pull. And then there's universal gravitation. Newton proposed that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses, and inversely proportional to the square of the distance between their centers. This law gave us a way to calculate the force of gravity between celestial bodies. Newton's laws held the fort for centuries, until a certain Albert Einstein entered the scene. The 20th century brought with it a radical change in our understanding of the universe, thanks to Albert Einstein. Albert Einstein, a physicist of unparalleled genius, proposed the groundbreaking theory of relativity. This theory, which was unlike anything the world had seen before, challenged the very fabric of our understanding of the universe. Einstein's theory of relativity is composed of two parts: special relativity and general relativity. Special relativity, proposed in 1905, introduced a new framework for all of physics by proposing that space and time should be considered together as a single entity, space-time. It postulates that the laws of physics are the same in all inertial frames and that the speed of light is constant in all frames of reference. This was a sharp departure from the Newtonian physics, which viewed space and time as separate entities. Fast forward to 1916, and Einstein shook the scientific world once again with the introduction of general relativity. This theory extended special relativity to include gravity, describing it as a curvature of space-time caused by mass and energy. This was a novel and profound shift from the Newtonian concept of gravity, which described it as a force acting between two bodies. Einstein's theory of relativity also had implications for our understanding of the universe as a whole. It suggested that the universe could be expanding, a radical idea that eventually led to the formulation of the Big Bang theory. According to this theory, the universe originated from an extremely dense and hot state and has been expanding ever since. Einstein's theories revolutionized our understanding of the very essence of reality. His work opened doors to a new era of physics, paving the way for the study of black holes, gravitational waves, and the accelerating expansion of the universe. Einstein's theory of relativity set the stage for modern cosmology. It gave us an entirely new lens through which to view the universe, and its influence continues to shape the course of scientific discovery today. In the realm of modern cosmology, the universe gets even more intriguing. We're now going to delve into some concepts that might sound straight out of a science fiction novel, but these theories are very much at the forefront of our current understanding of the universe. First, let's discuss dark matter. Unlike the ordinary matter that makes up you, me, and everything we can see around us, dark matter is invisible. We can't detect it directly, but we know it's there because of the gravitational effects it has on galaxies and galaxy clusters. It's like a ghost in the cosmic machine, elusive yet undeniably present. Then there's dark energy, another mysterious entity. It's a hypothetical form of energy that permeates all of space and tends to accelerate the expansion of the universe. Dark energy is the leading explanation for why the universe is expanding at an accelerating rate, a discovery that earned the Nobel Prize in Physics in 2011. It's thought to make up around 70% of the universe, yet we still know so little about it. Finally, we have the multiverse theory. This theory proposes that our universe is just one among potentially infinite universes. If you're having a hard time wrapping your head around this concept, you're not alone. It's a theory that challenges our understanding of reality and pushes the boundaries of our imagination. These concepts, although elusive and complex, are shaping our understanding of the cosmos. They remind us that the universe is a place of mystery, full of phenomena that we're still striving to understand. Dark matter, dark energy, and the multiverse theory are just a few pieces of the cosmic puzzle. As we continue to explore the cosmos, who knows what other secrets the universe holds for us? So, we've journeyed from the ancient geocentric model to the frontiers of modern cosmology. We've seen how our understanding of the universe has evolved, from the Earth-centered cosmos of our ancestors, through the revolutionary insights of Copernicus and Newton, to Einstein's profound revelations about relativity. Today, we stand on the precipice of new discoveries in cosmology that promise to further illuminate our place in the cosmos. While we have come a long way in understanding the universe, the cosmos continues to be a grand mystery, waiting to be unraveled. Until next time, keep wondering and keep exploring.